Hello and welcome, everyone. I am Rachel, and thanks for joining today's webinar on introducing supply planning in SAP IBP. This webinar is also going to include a short system demonstration. Now, before we start, I wanted to go ahead and introduce today's speaker, Ayanan Shu, who is a supply chain management solutions architect with over 17 years of experience in leading and managing supply chain solutions. Some of the industries that he has worked in are retail, CPG, and high tech. Now, he has utilized supply planning with IBP tool in his projects. If you have any questions during the webinar, feel free to type them into the discussion panel. We'll be answering all questions at the end of the presentation. So with that, I'm going to go ahead and pass it over to Ayan.
Thanks, Rachel, for introducing me to the team, and I'm immensely happy to be a part of this webinar. To get us started, I will begin with a quick overview of the supply planning process, just to set the foundation. And after that, we'll dive into a hands-on walkthrough of a supply planning use case, so you can see how everything comes together in practice. When you have got a good idea of what your customers want and you know how much stock you already have across your network, the next step is supply planning. This is where things start to get real. It's about turning the demand into an actual plan for what to make, how much to buy, and when to do it. At the core, supply planning is about figuring out how to meet the demand and what you will need to make it happen. Sounds simple, but in real life, it's balancing act. You have to look at what the market is asking and compare it with what your business can realistically deliver. There are always challenges related to limited raw materials, factory constraints, supply delays, or even transportation problems. In a perfect world, we would fulfill every forecasted demand, but in reality, we often cannot do so. And that's okay. Supply planning is about making the best possible plan despite those challenges. It's not about ignoring the problems, it's about working with them and finding smart ways around them. The process usually starts by taking the demand forecast, what the sales and demand planning teams expect customers to order, and figuring out how to actually meet it. For example, let's say the forecast says we will need 10,000 units of a product in the next month. That sounds straightforward, but now as a supply planner, you have to ask a bunch of practical questions. Can your factory produce the 10,000 units? Do we have the raw materials in time? Are the machines running smoothly? Do we have enough workers for extra shifts? Can our suppliers and transport partners support this plan? Let me give you a real example. Once I worked with a food company that makes instant noodles. Their Southeast Asia team forecasted a 30% spike in demand due to school holidays and promotions. Sounds great. But then there is a catch. A key ingredient, that is dried vegetables, was in short supply because of a poor harvest in Vietnam. Without that ingredient, production could not go ahead as planned. So now it was not just let's make 10,000 units, but rather what's possible given this situation. The supply team got creative. Now, procurement checked for alternative suppliers. The operation team looked into changing the recipe slightly to stretch the available stock. They even considered changing the production schedule or using another plant to help out. Every option came with trade off costs, delays, and impacts on quality, but they were all on the table. This is what supply planning looks like in the real world. You have to be flexible, work with different teams, and make decisions based on the best available data. And that's where the supply review comes in. The supply review is a meeting where everyone, like demand planners, the supply chain folks, inventory managers, finance, procurement, all of them gets together to look at the demand versus supply picture. The goal isn't to point fingers if something is not working. It is to find the practical solution as a team. Um, so back to the noodle example, let's say we can only produce 5,500 units out of the 10,000 needed. In the review meeting, the team might decide to send those 5,500 units to high margin markets or loyal customers. Marketing may adjust promotions. Finance might assess the cost of extra shifts or buying from a different supplier. If it looks like this, demand spike will continue for a while. The team may even suggest investing in a second vendor or a backup production line. The best part about these reviews is that they often lead to bigger strategic conversations. Maybe you realize this same supply issue keeps happening with one vendor. That could be a sign to diversify your supplier base. Or maybe your factory is always overloaded overloaded during peak seasons. Maybe it's time to invest in automation or expand capacity. So supply planning isn't just about fixing this month's problem, it's about building a stronger, more flexible supply chain for the future. And in my experience, it's one of the most critical and dynamic part of the whole planning process. So now let's discuss about the supply planning algorithms. We have the supply planning heuristics, which is infinite supply. So what will it try is that it will try to fulfill the customer demand no matter where the supply is, what are the production capacities is, right? So it will see that there is a shortage of stock in the supply chain nodes, but still it will result in the fulfillment of the customers demand. So heuristics is useful because if you know that this is my supply chain and these are the elements in my supply chain, like these are many plants I have, these many warehouses I have, and I have this transportation lanes laid out. uh, so what are the points in the supply chain where I am getting pushed out of the threshold? Where do I need to address the issue of understocking? Where do I need more inventory? Where do I need a production? And all those things. So all these answers are helpful to be obtained from heuristics. There is another algorithm which is optimization. So in optimization, what it does is that it actually tries to to fulfill the objective function. If your objective is maximum revenue, then it will try to maximize the revenue, reducing the cost of your entire supply chain, whether it is inventory handling cost, whether it is the transportation cost, whether it is the production cost. So it will try to respect the hard constraints, but it will try to minimize the overall cost of the supply chain. Whereas if your objective is to reduce where your objective is to maximize your delivery to your customer, right? You care less about your cost of your supply chain, but care more about fulfillment of your customers on time. Then your strategies differ, right? Your strategy of how you want to store your inventory, how do you want to replenish your stocks, how frequently you want to produce in your plants, and all those things actually differ based on your objective. So basically, these are the two main algorithms which you have in supply planning, and we will see in the use case of this algorithm. So what we see over here in this use case is that there are two customers. One is Costco and one is Target. And warehouse one and warehouse two are fulfilling the demand of these two customers. And there is a fulfillment ratio from each of these plants to the customers. So the target is getting in equal distribution from warehouse one and two, whereas 30% of the demand of Costco is made from warehouse two and 70% is made from warehouse one. Similarly, the plant 1 and 2 are fulfilling the demand of the warehouse 1 and 2. Within warehouse 1 is getting 30% of its demand fulfilled from plant 1 and 70% from plant 2, whereas warehouse 2 is getting 40% of its demand fulfilled from plant 2 and 60% from plant 1. Also, plant 2 is co-manufacturing with co-packer, and 60% is getting from co-packer, whereas 40% is in-house manufacturing. And also we have a component which is 1 unit of that component is going to 1 unit of the finished product, whereas component 2, 3 unit of this component goes to 1 unit of the finished product. So let's see how we can implement that. It's in the master data in IBP. So once you are in your IBP environment, you go to this TS supply planning configuration and you get the operators in this SNOP operator profiles tab. So you can click on the create tab And the create tab, you get an option of TS based supply heuristics and the optimizer, which are the main algorithms. So if we choose heuristics, you can provide the details, and also you can select whether you want to infinite heuristics without shortages, or you do not want finite heuristics. Also, there are other criteria like receipt balancing. You can choose them, and we are good to go. Otherwise, you can choose the optimizer also. So there is an optimizer profile, and here you can provide the details, and then in the general tab you can either go for profit maximization or delivery maximization. So if you want to maximize the full order fulfillment of your customers, then you can go for delivery maximization, and then if you want to maximize profit for your organization, you can go for the profit maximization mode. Also, there is some pseudo hard constraints where you want to maximize your profit, considering that you must also penalize the algorithm to not to fulfill any customer's demand. Otherwise, what the optimizer will do is that it will not suggest to deliver anything to the customer, because non-delivering is max and the most profitable one, right? Because the otherwise, if you deliver something, then you have to consider, you have to go undergo production cost, you have to undergo transportation cost and whatnot, and inventory holding cost and all those things, right? So it will, if your objective is to profit, maximize profit, then it will, you have to have some pseudo hard constraints of the as a penalty cost of not delivering your product to your customers, right? So these are non-delivery cost rate for delivery maximization. So we have seen what are the parameters of these algorithms, right? And now let's jump into the use case. So before jumping to the master data, I have created a summary of this use case. So the summary is that we are adding two components, and in the product master data, we must add those components. We must declare that in the unit of conversion factor, we should have a production source header where we are defining the source ID, and then we are having the production source item because it is a bill of material. So we are defining the bill of material in the component where we are saying that the component one is required in 1 unit for each finished product, whereas 3 units of component two is required. And then we have the capacity defined, we have the consumption rate defined for each unit of the product, and then we have the mapping of the components to the plants, right? So this is the summary, and let's quickly see the master data. So the master data, what we see first, we have the product. So in this, we have defined the product, and in the location, we have defined the locations related to this sub network. Then we have the two customers defined. We have the customer product defined, and we have the location product where all the locations are defined and mapped to the products. We are defining the products and the warehouse to the customers, and then we have the conversion factor, and then we have the location source, and then production source header, because we are defining the components. And since we are defining the components, so we are defining the production source item also. So where we have the component one, 1 unit of it is being manufactured, and 3 units is required for manufacture 1 unit of finished products. For component two, we have the resource, we have the locations, resource mapping, and the capacity of each machine defined, and then the production source resource mapping, and we have the production consumption rate, right? And before looking at the results, we see how to run the application jobs, right? Whether it is heuristics or the optimizer. So we go to application job, and there is an SNOP operator, and we click on run, and then we select the algorithm that we want to run, and then we select the a window or horizon over which we want to run, and then we select the network on which we want to run the optimization, right? The customer demand is fulfilled by the heuristics algorithm, and we see that the production happening in plant one is 1393 units, and plant two it is 2066 units. In the components, we have component one of 1393 units, because 1393 units is what the finished product is manufactured. So that is the same number of elements that we required for component one. Similarly, for plant, we have 2066 units. which is the same number we are producing the component 1 in plant 2. Whereas component 2 needs 3 units to produce 1 unit of finished product, right? So if I multiply this multiplied by 3, so we see that we get 4180. Similarly, if we multiply 2066 by 3, then we get the same number as we have get component 2 manufactured in plant 2. And we see capacity now. So capacity, what we see is that we see that out of the whole capacity in the machine in plant 1, the 77% of it is consumed in week 1, whereas 86% of the plant two's machine is consumed. So on an average, if you see on this week, actually, there is a very, very low consumption of the machine in this week, whereas there is a high consumption of the machine for this week in this plant, right? For the component in this plant. So what we can do is we can rearrange the quotas on that particular month, on that particular week, or try to rearrange the quota for the entire thing, because the average consumption, if you see over this planning horizon, it is 85% for the plant 2, whereas this is around 52%. So the plant 1's machine is consumed on a much less on average rather than the plant two's machine. So what we can consider is go to the master data and try to rearrange the quota that we have defined in the master data. So we can see that plant 1 is supplying something to plant to the warehouse 1 in certain ratio. So we can think of to change the ratio and see what is the impact on the capacity utilization. So this is a typical what if scenario that we can perform in supply planning. So this concludes my presentation on supply planning.
Thank you for that insightful session. We've received a few questions from the audience, and I'll read them out one by one for you to answer. The first question is, how does SAP IBP handle supply planning constraints like capacity and material availability? Next up, what is the difference between heuristic and optimizer in SAP IBP supply planning? And finally, how do scenarios support supply planning decisions in SAP IBP?
In SAP IBP, supply planning constraints such as production capacity, component availability, and supplier lead times are modeled using key figures and master data. The planning algorithms, whether heuristics or optimizer, use this information to create a feasible supply plan, ensuring that production and procurement decisions respect the defined constraints. Now, on the second question about the difference between heuristic and optimizer in the IBP supply planning, the heuristic generates a supply plan quickly based on predefined rules without necessarily optimizing cost or resource usage. The optimizer, on the other hand, evaluates multiple scenarios and generates an optimal plan that balances cost, service level, and capacity constraints, but it takes more time to run and require detailed configuration. And coming to the third question about how do scenarios support supply planning decisions in IBP. So scenarios in IBP allows planners to simulate different versions of the supply plan, such as changes in demand, capacity, shifts, or supplier days without affecting the live data. So this helps in comparing outcomes and making informed decisions during the SNOP or supply review meetings.
That concludes our session. Thanks everyone for attending this webinar.